we are moving on with the third of 5 rules, CO12, simplified expression with a 0 power. Now, on paper, this rule seems to be the easiest because it only applies when you have an exponent of 0. Okay, and it's pretty straightforward. However, it requires a solid understanding of the difference between a base and a coefficient. Okay, and so we're going to start with the rule, and then we're going to explain it a couple different ways. So I'm going to scroll down here a little bit. This is a key point. This can go on a help sheet here. But when a base has a 0 did you all see that? My finger was not touching the board, and it shot up like that. Okay. When a base has a 0 power, this time the coefficient is what stays the same. Because remember, a coefficient is not affected by the power, right? So if the exponent's 0, the coefficient not being affected by the power, normally we're used to the base staying the same, but in this case, the coefficient stays the same. The coefficient does not change. The base becomes a 1. The base becomes a 1. For example, if you have the expression n to the 0 power, n is the base, it has the 0 power, n to the 0 is equal to 1. Okay? Can a base be a number? Can a base be a number? Sure it can. Okay? Let's say you had 106 to the 0 power. 106 is a base. The base becomes a 1. 106 to the 0 power also equals 1. Where the coefficient comes into play is if you've got an expression with a 0 power, but you have a coefficient, say 7n to the 0, the base of that 0 power is what? N, which means that n becomes a 1, right? Or n to the 0 is equal to 1. That 7, that doesn't have the 0 power. The 7 is not affected. That's a coefficient. The 7 stays the same. So this expression actually becomes is 7 times 1, because n to the 0 becomes a 1. 7 times 1 equals 7. Okay? In a nutshell, the rule is that any base to the 0 power is 1. Summarize this in one sentence. Any base to the 0 power equals 1. So again, on paper, it seems super simple, right? I've got a 0 exponent equals 1. Great. But sometimes simplicity can lead to complacency, right? Sometimes if something seems very simple, you just kind of ignore the details because you think it's super easy. So let's take a look at why this works here, okay?
Is Edward in here?
No, he's in theology. Oh, thanks. Let's talk about the property of division, okay? Finish the sentence for me. Anything divided by itself equals...
Itself.
Ooh.
1.
Boy, 1, right? You've been doing this. 9 divided by 9 is 1. 8 divided by 8 is 1. The whole purpose of opposite operations, if you've got something like 11n equals 99 and you want to solve for n, the reason why we divide by 11 here is because 11 divided by 11 equals 1, right? We have 1n left, and that equals 9, okay? So anything divided by itself equals 1, right? You learn that. You should learn that 4th grade when you started division. So if we take this in the terms of powers, we can take something like n cubed and divide it by itself. And what are we guaranteed n cubed divided by n cubed to equal? 1, because it's something divided by itself, right? Basic rule of division. Anything divided by itself equals 1. Okay. Now, let's look at that same expression, n cubed over n cubed, and let's think about this in terms of CO11. Dividing by the same base, what we just did. According to that rule, according to CO11, dividing by the same base, what can we do with those powers? To simplify. CO11 dividing by the same base, what happens with the exponents? They get subtracted, right? What's 3 minus 3? 0. So we can rewrite this n cubed over n cubed to equal n to the 0 power. Because using that rule in CO11, the powers are subtracted, 3 minus 3 equals 0. Everyone follow me so far? You agree that anything divided by itself equals 1, and you agree that these exponents can be subtracted based on the rule from CO11 to equal 0, yes?
Yeah.
Okay. Have you ever heard of the transitive property before? It's a geometry thing, but basically the transitive property says that if A equals B and A equals C, what's the relationship between B and C?
They both equal A.
They equal A, and what else?
They're the same.
They're equal to each other, right? If A is equal to B and A is also equal to C, then B has to be equal to C because they're both equal to A. That's what's going on here. If n cubed over n cubed is equal to 1, and n cubed over n cubed is also equal to n to the 0, what must be true about n to the 0 and 1? They're the same. They're equal, right? If the same expression, n cubed over n cubed, equals two different things, those two things have to be equal. And because we're using a variable here, and a variable can be anything, that means that anything, any base, to the 0 power equals 1. Bless you. Nolan.
What is that thing called?
The transitive property. It's a geometric property. When you do proofs next year, the transitive will be all over the place. It's a big one. Okay? But we're using it here to help us explain why something to 0 power equals 1. Questions? I know maybe for some it's kind of like, woo, that's way up there stuff. And it is. Okay? When you prove something using math, it can get fairly complicated, but if you can wrap your head around this relationship, this explains why the rule is what it is. Okay? Now on to the practice. Here we go. Here we go. The most commonly made mistake is simply not following the rule. Only the base of the 0 power equals 1, not the coefficient. Only the base. Okay? So the first one, n to the 0, we've already seen that. What does n to the 0 equal? It equals 1. Okay. The next one, x to the 0 times y to the 0. X to the 0 times y to the 0. What does x to the 0 equal? 1. What does y to the 0 power equal?
1.
1. We're multiplying those two things together. What's 1 times 1? 1. Okay. Now, is every answer on this page going to be 1? No, right? That'd be way too easy here. But I'm showing you all the different ways that these things can interact. 3,481 to the 0 power. Is that 3,481 a coefficient or a base?
Base.
A base. The 0 power is attached to it, right? So what does 3,481 to the 0 power equal? 1. 7y to the 0 power. Here we introduce a coefficient. And this mirrors very similarly the one that you have in the example up above there. The base of the 0 power. Raise of hands. What is the base of the 0 power? Josie. Because I asked. So y to the 0 power equals 1. Our coefficient of 7 times 1 equals 7. See, now, Josie, that was a trick because it's Halloween. That was a trick. Oh, okay. Sorry. Negative n to the 0 power. What's the base of that 0 power? Nolan? N. So only n to the 0 power equals 1. That coefficient, negative 9, just drops down. It's not affected by the power. And so negative 9 times 1 equals negative 9. Okay? I give you this little nifty tidbit up here, my little moniker, if you can see it there. Whenever you have a 0 power in an expression, you can kind of just ignore it, right? Like 7y to the 0, if we just kind of ignore the y to the 0, what are we left with? 7. That was our answer. Negative 9 to the 0 power, or 9n, if we ignore that n to the 0 power, what are we left with? Negative 9. That's our answer.
We just do that with every single one?
Kinda. I mean, for the next one, x cubed y to the 0 z squared, that's saying we have 3 x's, 2 z's, and no y's. So, okay, let's just get rid of them, right? And what are we left with? X cubed times z squared would be our final answer. Really what's going on here is that y to the 0 equals 1, so we have x cubed times 1 times z squared, but multiplying x cubed by 1 doesn't change the value anyway. Why include it? Why does it even matter? It doesn't. Okay. Is there one on this page that you want to go over? I will go over a couple more before time is up. This is the treat part here. This is before it was a trick. Now it's a treat. Any you want me to go over? Josie, is there one you want to talk about? You don't know what you want, no? Mia.
Last row, second question.
Is that the x to the 5th one?
This one.
Yeah, x to the 5th times x to the 9th. Is that right? So x to the 5th times x to the 9th times y to the 5th over x to the 14th times y cubed. Well, just like we did in the homework for today, we're going to simplify our numerator and our denominator first. So what can we combine in our numerator there? X to the 5th times x to the 9th times y to the 5th. What can we combine? And what's the result? I see that multiplication symbol, so I'm thinking multiplying by the same base. How many x's do I have in total there? Yeah.
Wait, which one?
X to the 5th times x.
You have 14.
X to the 14th, right? Put it over here. In total, I have 14 x's up top. I can't do anything with that y to the 5th because it's not the same as an x. In my denominator, I also have x to the 14th. And I can't combine them with the y cubed because, well, the y is not an x. Now, how does a question like this relate to the whole idea of a 0 power? Take a look at what we have now. We have x to the 14th, y to the 5th, over x to the 14th, y cubed. How does this relate to the little 0 power rule? Well, it looks to me like I've got 14 x's up top and 14 x's on the bottom. What's anything divided by itself? 1. These 14 x's completely cancel out. And I'm left with y to the 5th over y cubed. What does that simplify down to be? Y to the 5th over y cubed. Landon? Y squared. 5 minus 3 is 2. Those 2 y's are in the numerator because that's where I had more to start with. And so y squared would be the answer. Okay? Excellent. Homework for tomorrow. Let's do the number game. Homework for tomorrow. Finish the page, CO12, and then tomorrow we'll get a little bit negative. Negative powers. All right. That's how I math, folks.